Today I will talk about mathematical basis of DBSCAN clustering algorithm. It is part of my series of lectures on machine learning. So DBSCAN is abbreviation of density-based spatial clustering of applications with noise. It is a type of unsupervised machine learning algorithm. It does not require prior information regarding number of clusters, unlike other methods of clustering like k-means. It is based on the distance between neighboring data points, and hence it is based on the density of points. So I have taken information from the internet resources and I have acknowledged the resources at the bottom of my slide. So this is a picture I have taken from this source. So if these are the data points, we classify each data points into various types. Let this be a parameter specifying the radius of a neighborhood. So if this is the radius of the neighborhood of this point, point P is a core point if at least m points are within a distance of this, including the point P itself. So these two are the parameters of the DBSCAN algorithm. So in this example, if we have as m is equal to 4. So if m is equal to 4, then this point contain 4 points, including this point itself, within a radius of epsilon. A point Q is directly reachable from point P if point Q is within the distance of this from core point P. Note that points are only said to be directly reachable from core points. So B is directly reachable from the core point, this core point, and C is directly reachable from this core point. And these two core points are also directly reachable. A point Q is reachable from P if there is a path P1 to Pn where P1 is equal to P and Pn is equal to Q, where each Pi plus 1 is directly reachable from Pi. So each successive point is reachable from the previous point. Then point Q is reachable from point P with points in between. Note that the initial point and all points on the path must be core points, with the possible exception of the last point. So if this is our Q point and this A is our P point, then this B, that is Q point, is reachable from point A. And it is noteworthy that all the intermediate points are core points except for the possible exception of the last point. All points not reachable from any other point are outliers or noise points. So this point, blue color point, is not reachable from any other point. So this is the noise point or outlier point. Reachability is not symmetric relation. By definition, only core points can reach known core points. Density connectedness. What is density connectedness? Two points P and Q are density connected if there is a point O in between such that both point P and Q are reachable from O. And density connectedness is symmetric. So point B and C are density connected with each other. If P is a core point, then it forms a cluster together with all points that are reachable from it. So if A is a core point, it is forming a cluster with all the points which are reaching from point A. So point B is also and C is also reaching. So point all these red points and the yellow points form a cluster. However, the red points are core points and B and C are the border points. Hence, each cluster contain at least one core point. Also, non-core points can be part of a cluster, but they form its edge. For example, B and C points in this, they are part of this cluster, but they form edge, since they cannot be used to reach more points. So what are the features of our DBSCAN algorithm? DBSCAN algorithm does not require to specify the number of clusters beforehand. It can find arbitrarily shaped clusters. This is the advantage. It is robust to outliers. The concept of outlier is not there in other algorithms like k-means. It is not entirely deterministic. That is, we achieve different results. So border points that are reachable from more than one cluster can be part of either cluster depending on the order the data is processed. Cluster of DBSCAN depends on the distance metric used. DBSCAN cannot cluster data sets well with large differences in densities because this is density based clustering. So there is large differences in densities of various clusters and this algorithm will not produce good results because the parameters m and epsilon cannot be chosen appropriately for all clusters. If the data and scale are not well understood, choosing a meaningful distance threshold epsilon can be difficult. So how do we choose the parameters or select the parameters? So parameter estimation, there is a very good resource on internet. This is the link for that resource, which describe how to choose the right parameters. There are these three parameters in DBSCAN. One is the minimum points m, the other is the distance epsilon, and the third is the actual distance metric used. Mostly Euclidean distance metric is used, but in higher dimension, this metric may not be very useful. This is a very useful animated diagram which is taken from this internet resource. Copyright remain with this resource. I have just copied it here for so that you can understand it better. So this is the animated diagram how the algorithm work. It classify each and every points. So this is all for today. Thank you very much.